Regents Review number 13. In this first question, you're asked to modify the formula for the perimeter of a rectangle, P equals 2L plus 2W. In doing so, in solving for L, which one of these three equations is correct? So if we want to solve for L, the first thing we need to do is use an inverse operation and a property of equality to remove 2W from the right-hand side, leaving us with P minus 2W equals 2L. To isolate the equation for L, we would need to divide by 2. And here's where you have some options. One option is you could divide the entire side by 2, which would give us a match to option 3. Another option would be to divide every term individually by 2. And that would give us half P minus 1W is equal to L. And that matches option 1. The only one we're unsure of is option 2. So how we check that is to distribute this here to get 1/2 P minus W and see if that is equal to any of the other items. And it is. So that means 1, 2, and 3 are all the same. Question 2 asks you to write a system of equations that can be used to find the price of a bag of popcorn and the price of one drink. So it looks like we have bags of popcorn. So maybe we'll use P for popcorn and D for drinks. So don't forget, you always have to identify your variables, even if you're using X and Y, or if you're using letters from the actual words. So Jacob spends a total of $18.25 when he buys 2 bags of popcorn and 3 drinks. And Zachary spends a total of $27.50 when he buys 4 bags of popcorns and 2 drinks. So there's our system. The next thing they ask you to do is to determine and state the price of a bag of popcorn and a drink to the nearest cent by using these 2 equations. So you have a couple of options for solving here, but if you have to show your work, then you're either going to use elimination or substitution. So let's see, I think I'm going to use elimination. So in order to do that, I need to have matching coefficients with different signs. So I think I'm going to multiply everybody here by -2. And by doing that, on the right side, I'll get -4P. And that's exactly what I want, because I want it to eliminate with the positive 4P that I already have. Now all I have to do is get my calculator out, so I can multiply 18.25 times -2. And then I'm also going to do some subtraction when I finish this off. So -3650. And then I had 2750 here. So now when I add these together, I'm going to get -$9 is equal to -4 drinks. Divide both sides by -4. And I'm going to get the drinks is equal to 225. Now that I know the drinks, I can use that value to find the popcorn. So I think I'll use the first sentence, 1825 equals 2P plus 3 drinks. And now I have a value for D, so I'm going to put that 225 here. So 1825 is equal to 2 popcorns plus 675. Subtract 675 from both sides. We're going to get 1150, and then divide both sides by 2, and we're going to get 575. Number 3 asks you to graph this function. It's piecewise, so one piece is going to be an absolute value function, and the other piece is going to be a constant function, or a straight horizontal line. Now look carefully at the restrictions on the domain. So from -3 to +1, this section of the graph can only be this absolute value function. And then from 1 to 8, this section of the graph will only be this constant function. So the absolute value of x is what I'm looking for. Whoops. For the first few points. And you'll notice I have a greater than or equal to, x is greater than or equal to, but here it's just a less than. So here I'm going to get 3, 2, 1, 0, and here I'm also going to get 1. So -3, +3, and then at this location, I'm going to get an open circle. Notice, no arrows. And now, for the numbers 1 through 8, the answer will always be 4. So 1, 2, 3, 4 with a closed circle because I have an equal to sign. 4, 4, 4, 4, 4, all the way up until +8. And there's my piecewise function. In order to write an exponential equation, you need some perfect corner points. So it looks like I have the points 2, 1, 4, 4, and I think that one is 5. This looks like 5, 8. And now what I'm going to do is I'm going to turn my calculator on, press the stat button, and put these points into my list. So I've got 2, 4, and 5. My y values are 1, 4, and 8. Now I'm going to press stat again, but this time I'm going to calculate an exponential regression because that is an exponential curve. So I'll press enter a few times here, and I get a is 0.25. Y is equal to 0.25, and B was 2, raised up to the x power. And I can say, I located 3 points on the curve and calculated the EXP reg. Calculate the exponential regression. Number 5. Write the correlation coefficient for the line of best fit by rounding your answer to the nearest hundredth. So again, we're going to go back to our calculator, and we're going to clear out anything that's in the stat menu. So I'm going to arrow up and press clear and enter, and again, press up and clear and enter. And before I do that, I can't get a correlation coefficient unless the mode has been turned on for stat diagnostics. So I have to go down to stat diagnostics, arrow over once, and turn it on. Now I'm going to enter all of this data into the list 1 and list 2. Now it's very important to triple check this data because you're not going to have any idea if that correlation coefficient is right or not. If you type 1 digit wrong, you'll have no idea the correlation coefficient is wrong. So let's just double check this data, not missing any digits. And this data here, everything looks good. Now it asks us to write the correlation coefficient for the line of best fit. So that means we need linear regression. So that's number 4. We press enter 5 times, and the correlation coefficient is right at the bottom, It's the R value, not R squared, the R value. And they want it rounded to the nearest hundredth. So let's see here. To the nearest hundredth, the R value would be 0.94. And now it wants us to explain what the correlation coefficient suggests in the context of the problem. So we're going to say there is a strong positive correlation between X and Y. So between calories in a hot dog and milligrams of sodium. If you'd like to add a bonus sentence here, then you can use this sentence starter. As the X increases, right? But instead of the word X, we're going to use the label from the chart. As the calories, ran out of room. As the calories increase, right? As X increases, that's a sentence starter. It's always going to start like that. As X increases, and then this is where it changes depending on the table. As the calories increase, the milligrams of sodium do what? They also increase. And I know that because the correlation coefficient is positive. So the first one is always an increase. The second one depends. Number 6. They're asking you to find the area of Fred's rectangular piece of paper. It has a width of 2x minus 6 and a length of 2x minus 6 and a width of 3x minus 5. So we could use an area model, and we could do that like this. 6x squared and negative 18x, and then we've got negative 10x and positive 30. Or you could set it up as a binomial times a binomial, and you could FOIL like this. Either way, we're going to get 6x squared minus 28x plus 30. Number 7 asks you to rearrange this formula here, the volume for a cylinder, and they're asking you to solve for R. So if I have volume equals pi r squared h, then I can divide by both pi and h at the same time, giving me volume divided by pi h equals r squared. And in order to get rid of a square, you have to square root. So there we have it, the square root of v over pi h. In this example, they have two exponential functions, and Miriam is using f of t equals n to the 2t power, and Jessica is using g of t, which is n to the 4 times t power. And it says that if Miriam starts with 16 bacteria, which would be the n in this case, then how many bacteria should Jessica start with to achieve the same growth over time? Well, we can think of this using our exponent rules, and that would be that n times 2 times 2t, right, you see that, would give us the same exponent. And if you have the same exponent, and you want them to be equal, then you have to have the same base. So we're thinking of what number times itself would give us n squared. So that's how we get this answer of 4. Now let's say you don't know, or you're not recognizing it. If we know that this one is 16 times 4 to the t, because we are told, Miriam is using 16 times 2 to the t, right? And we are told that she starts with 16. All you have to do is use your graphing calculator by putting in the y equals the function that you know. So in the y equals, I'm going to put 16 raised up to the 2 x power, right? 2t. And then in the other one, I can guess and check. I can say 32 raised up to the 4x power, and I can look at the table and see if they are the same. And no, they're not. So I go back, and instead of a 32, I type a 16. And I go and I look at the table, and I see if they're the same, and they're not. So then I go back, and I put in a 4, and I see if they're the same, and they are. And so that's another strategy for how you could solve this problem. Question number 9 says you're going to graph two functions on the same set of axes, and it asks you what is true about the solution to the system. Now, before I even read anything, what do we know to be true about any system? Whether we have a quadratic and a linear, whether we have an absolute value in a linear, right? It doesn't matter. The solution to the system is always the points of intersection. And the points of intersection always lie on the line, or they are always a solution because they satisfy the equation. So we don't even know. I haven't graphed it. No clue where these two functions intersect. I have no clue. However, these are my options. So it doesn't even matter what the point is. Does this make sense? Are you a solution if you satisfy one equation? No. Are you a solution if you satisfy this one equation? No. You have to satisfy both equations. So I don't even need to do this problem to know that the answer is 3. However, if I wanted to, I could graph this in my y equals button. I could isolate y in this problem. And I could graph that in my y2 button, and I could take a look to see if 6, 3 is indeed a point of solution. So let's take a look. The first function is absolute value of x minus 3. And the second function is negative x plus 9. So we can look on the graph or we can look on the table. So we're looking to see if the point 6, 3 is on both, and it is in both tables. I could also look at the graph, and I can look at the absolute value function being graphed. Then I can look at the linear equation being graphed, and I can see that they indeed intersect at this point. Question number 10. How does the graph of 3 times the quantity x minus 2 squared plus 1 compare to the parent function of x squared? So it looks like we have a number out here, we have a number in here, and we have a number over there. And these locations all do something different. This one is a dilation, this one is a translation left or right, this one is a translation up or down. So I know without thinking that this is a translation up. So I'm just going to scan here, and they all say it, so I no longer need to think about this one. When I scan in the middle here, I know this is a translation to the right. So I'm going to scan here and see what we have. 2 units to the right. So that means this one is out and this one is out. Now all I need to know is that a dilation is something that stretches you and makes you skinnier or more narrow. So we know that the graph is going to be more narrow. And if you weren't sure, you simply turn your calculator on, you type in the y equals your x squared function here, and then you type in y2, 3 parentheses, x minus 2 squared plus 1, whoops, and you can watch it being graphed. So this is the parent function, and now this is the new function, which is 1 up, 2 to the right, and more narrow. This one asks you to write an equation for if you're going to mail something, right, up to 1 ounce, or how much it costs if you go over that amount. But first, you're going to be charged an initial fee of 46 cents, no matter what. The only way the price will change is it may go up or down, well, up or stay the same. It may go up 20 more cents every time you have an ounce more. So the 46 is a constant. So that means that this is out and this is out. There it is. The 46 cents is a constant. Now the question is, do you pay 20 cents for every ounce or just the ounces except the first one? And that's why option 4 is the right answer. This would be if you had to pay 20 cents for every single ounce. This one is only the ones, but take away the free ounce. And that concludes Regents Review number 13.